right, so this is exam 1 2023 VCE exam, and this is meant for year 12 students doing maths method. And all right, let's have a look at the first question of the exam. So this is based on the quotient rule, so which says the derivative of, so that's going to be u, whatever, on the numerator of the denominator, which is v. So u prime v dotted with v minus v prime dotted with u over v squared. So that's what the quotient rule says. So now the u prime is 2x minus 1 and the v prime is e to the power of x. So now my dy, and also we need to make sure that we answer what the question is asking us. It's asking us to simplify after we get the answer. So that means 2x minus 1 e to the power of x minus e to the power of x again. So x squared minus x e to the power of x. So we square the v, which is e to the power of x. So that means take the common factor out, in this case e to the power of x. So that gives us 3x minus 1, collecting the like terms, over e to the power of 2x. So that on my denominator I'll end up having e to the power of x. So that's gone. And that's my 2-mark question. All right, the next one is based on the product rule, so in which, similar as the quotient rule on your numerator, the only difference is the plus. So if we say this is u and that's v, so the product rule will be u prime v dotted with v plus v prime dotted with u. So u prime is cos x and v prime is 2e to the power of 2x. So f prime x gives us and cos e to the power of 2x plus 2e to the power of 2x sine x. Take the common factor out, so in this case here e to the power of 2x, so we also need to substitute quarter pi. So that gives us to be half pi, because multiply by 2, so that's half pi. So into bracket cos a quarter pi plus 2 sine quarter pi. All right, so that gives me, so that's the square root 2 over 2. So times 2, so that's going to be square root 2. So e to the power of pi over 2 square root 2 over 2 plus square root 2. So 2 times square root 2 is going to be 2, plus 1 is going to be 3. So that's going to be 3 square root of 2 over 2 e to the power of pi over 2. So that finishes question 1. So let's move on to question 2. So question is asking us to solve. So solving means you get the x value. So in this case here, let's say let a be e to the power of x. So that gives us a squared minus 4a minus 12 equals to 0. So we need to find out two numbers. When you multiply, gives you negative 12. And when you add those two numbers, gives you negative 4. So that's going to be a squared minus 6a plus 2a minus 12 gives us 0. So the common factor here is a. Take the a out. A minus 6. So the common factor is 2 here, which is 6 there. So a plus 2, a minus 6. So therefore a equals to negative 2 or 6. So the fact that the natural log of a negative number does not exist, therefore x must be the natural log of 6. All right, that finishes question 2, 2-mark. All right, sketch the graph f of x 2 minus 3 over x minus 1 on the axis below, labeling all the asymptotes with the equations and also the intercepts x and y. So now let's start with labeling the horizontal and the vertical asymptotes. So my horizontal asymptote is going to be 2. So my vertical asymptote is 1. So that's going to be 1 on there. So now if I substitute 0 there, so that gives me 2, 3 over negative 1, which is 5. So my y-intercept is 5, so up way there. So somewhere there. Oops. Oops. Do it again. So we also have to put in the coordinate format. Also, when y equals to 0, so that's going to be 2, 3 over x minus 1. Just take that one out. So that gives me 2. So that's going to be 2x minus 2 equals to 3, which is x equals to 5 over 2. So which is somewhere there. Oops. Let me graph this. It's hard to get it straight there. All right, that's going to be 5 over 2, 0. So those are my intercepts. Find the values of x for which f of x is less than 1. So that means 2 minus 3 over x minus 1. The whole thing equals to less than 1. So that means if I take that the other side, so that gives me negative 3 x minus 1 is less than negative 1. So if I multiply that, that gives me, so now that gives me x as to be, I think I need to use this area here. So that gives me negative 3 less than negative x plus 1. So that is negative 4. So divide negative 1 on both sides. So that gives me, so therefore, but x cannot be 1 though, because if x is 1, that means that's undefined. So that's a vertical asymptote. So that means my x value can only be those values. So it can be written as this one as well. All right, so my x values is that. The graph y equals to x plus 1 over and x is shown over its domain. So the domain is over part of its domain. So that's going to be only the positive part. So the negative hasn't been drawn, that is. All right, use two trapeziums of equal width to approximate the area between the curve, the x-axis, and the line x equals to 1 and x equals to 3. So that means this line here two trapeziums. So we have to establish two trapeziums. So using ruler. So this is one trapezium, and we need to find out the value. So that's 1. So 1 that's going to be 1. That's going to be 1, 2. And if I substitute 1 there, I'll get 2. Well, 2 there. So that's going to be a half plus 2 is going to be 5 over 2. So 3 there. 3 plus a third is actually 10 over 3. All right, now we know that area of a trapezium equals to half base, half height plus A plus B. All right, so now here, this section here, if I label that to be B and that's A, and that bit here is my H, and H equals to 1. So my trapezium, so my area has to be a half, which is times H is 1. So this is the first one. So that's going to be 2 plus 5 over 2, because that is my, if I say this is my A and that's my B, whatever, plus a half, 1 into bracket. So that's going to be 5 over 2 plus 10 over 3. So that gives me 9. So that's going to be 9 over 4. 9 over 4 there. So that gives me 15. 15 plus 20 is 35. 35 over 6, isn't it? 35 over 6. Am I right? So 35 over 6. Yeah, that's 35 over 6. Well, 35 over 6 times 2. So that's going to be 12, isn't it? That has to be 12 because, yeah, that half there. All right, now, so that means, well, 4 goes into 12. 3 times 9 is 27. 27 plus 35 must be 62, isn't it? 62 over 12. I can simplify that to be 31 over 6 units square. So that's my area for question 4. That finishes question 4. So let's move on to question 5. So the question here, the next one is asking us the integration of sine. So this is, I also made another lesson on this, the sine. So if you integrate here, so that becomes negative cosine by using, well, that's also in the formula sheet, but having said that, it's better to know what you're doing. All right, so that's going to be cos. So if you integrate, sine becomes negative cosine, so that's going to be negative cosine. So my upper bound is 3, my lower bound is 0. So that gives me, it's actually pi on 3, I should say, pi on 3. So that means negative pi on 3, well, negative cos pi on 3 minus another minus 0. So that is a half. So that's going to be negative a half. That's going to be 1, which gives me a half. So that bit is half. Hence or otherwise, find the value of k such that the integration of sine from 0 to a third pi equals to this, where k is in this interval. All right, now, so we already know that that's a half. So all we have to do is we're going to say, so that's going to be cosine. The integration of cosine is sine. So sine a half pi minus sine k. Oops, that has to be k, not that. Fix that. The whole lot equals to a half. So that means sine half, that's 1, minus sine k, a half. So if I take this, that's going to be negative a half, negative, so that's going to be k equals to sine inverse a half. Yeah. So now we know back in our unit circle. All right, let me just get a better drawing. A unit circle here. We know that sine is positive in the first quadrant and the second quadrant. So that means sine half a pi is actually pi on 6. So this is going the anti-clockwise direction. So that's going to be 2 pi, and that's half a pi. So it's actually positive in the second and first quadrant. So that's going to be 5 pi. Also, we need to remember that by going the clockwise direction, so that's going to be, well, if that's my first quadrant, second quadrant, so that's going to be again here. So that must be, well, that must be, if that's my second, that's going to be the fourth quadrant. So it's going to be, well, first, second, third, and fourth. So the fourth quadrant. So my k value has to be, well, the negative in that quadrant. So that means you have to add another pi. So that's going to be, and because add another pi. So that's going to be pi on 6 first, 5 pi on 6. And also, if that is negative pi over 6, so that's going to have to be negative 5 pi on 6. So this side here, because it's going to be in the third and the fourth quadrant when you go the clockwise direction, so that means it's going to be 7 pi over 6. So that's going to be 11 pi over 6. So therefore, that's going to be negative 11 pi over 6 and negative 7 pi over 6. So therefore, my k value is going to be negative 11 pi over 6, negative 7 pi over 6, pi on 6, and 5 pi on 6. 5 pi on 6. All right. That finishes question 4. So let's move on to question 5, I should say. Let p hat be that random variable that represents the sample proportion of households in a given suburb that have solar panels installed from a sample of randomly selected households. So now the 95% confidence interval. So when I get the p hat, so that's going to be and the lower confidence plus the upper confidence divided by 2. That's going to be 0.2 divided by 2. That's going to be 0.1, which is 1 over 10. All right, now find the sample size. So that is asking us to find the n value from the 95 and the z we use. So we know that. So that's going to be plus or minus z square root p hat 1 minus p hat over n. So that's my confidence interval. So if I use the upper confidence interval, so it's going to be 1 over 10 plus 2 square root 1 over 10 times 9 over 10 over n. The whole lot equals to 16 over 100, because better to deal with fractions than decimals. So if you take this on the other side, that gives us 6 over 100 divided by 2. So that gives us the square root of 9 over 100 over n. The whole lot equals to 6 over 200. So square both sides, so that gives me 36. So that gives us 9 over 100 n gives me 36 over 40,000. So what do I get? So that's going to be, so multiply that, so that's going to be, all right, 3600 n equals to 36. 9 times 4 is 36. Add 4 more zeros, so zeros will cancel, so I'll be left with 2 zeros. So that bit there divided by that, so that gives me 100 samples. So the answer is 100 samples. All right. A large household is selected as well. So with a sample size of 4 times the original sample, the sample proportion of households having solar panels installed is found to be the same. But by what factor will the increased sample size affect the width of the confidence interval? So that basically means margin of error. And we know that the margin of error equals to P1 minus over n, but that n has been multiplied by 4. So that basically means P1 minus 4 times over 4. So that means square root of a quarter times the margin of error, which equals to a half. Therefore, the increased factor is a half. All right, so the next question is, which is question 7. So question 7, we have an f of parabola, which has been restricted. And the question is asking, as part of the graph y, so state the range. So basically here, so let's actually label this one is 1, -1. So the range is, the range is -1 to positive infinity. Okay, awesome. Sketch the graph of the inverse of f of x on the axis below. Label any endpoint actual intercepts with their coordinates. So now here, so the y becomes x and the x becomes y. So this point here, so that's going to be, that's my endpoint, because that's the only point we are certain. And that bit there, it's going to be a mirror image. So that also there, which is easier, because this is it's going to be, oops, should I start from this end then? Oops, I just sort of missed it. I want to hit this side. All right. Just missed the wrong. Oops. Just missed that one again. Can I go more of this? Yeah, there we go. I should go this one here. Much easier when it's on the paper. All right, now the next bit is the terms of that, the equation. All right, determine the equation of the domain for the inverse. So we want to find out the inverse. in order to do that, my f of x is x squared minus 2x. So first and foremost, I would actually use completing a square, especially for this type, to inverse it. Completing a square, that's the first thing you're supposed to be using it. So my f of x has to be x minus 1 squared minus 1. So that's my completing square. So now I can transpose after I've done that. And where x equals 2, so x equals 2, and y minus 1 squared minus 1. So that, take that to the other side. So that's going to be x plus 1 plus or minus square root plus 1, plus 1 equals to y. But then again, we have plus or minus. Which one should we take? So that means this is a mirror image, and we know that the line, which is this one here, y equals to x, is a mirror image. So now that is the negative side, so we take the negative side. Therefore, my inverse of f of x is going to be 1 minus the square root of x plus 1. And the domain, that's the equation, the domain. So the domain is the range of the original function. So that means domain of is negative 1 to positive infinity. All right, so now calculate the area of the region enclosed by the curve f of x, the f of x inverse, and y equals to negative x. So that basically means if y equals to negative 1, so that must be here, that bit there, and that bit there. So those are the areas we're actually finding out. So if I get this bit here, that bit there, so from there to there is going to be 0 to 1. So that's going to be my lower bound is 0, my upper bound is 1. So what I could say is they are both symmetrical. All right, so I could say the area to that, so it has to be, the area has to be 2, 0 to 1. My upper curve is negative x minus, if I use this one here, if I use that, x squared minus 2x, which is, so this, the upper curve is actually x minus 1. X is minus x, I should say. So that's going to be x squared minus 2x d of x. So now if I expand that, what do I get? X, isn't it? So that gives me that negative x squared plus x d of x. So that gives me negative x to the power of 3 plus x over 2, x squared over 2, 1, 0. So my area has to be 2 into bracket. So that's going to be negative a third plus a half. Well, that's going to be 0. So 2 minus 1 is 1/6. That's 6, you cross multiply. So that gives me 2 over 6, which is 1/3 units square. So that is question 7. So let's have a look at question 8 now. Question 8 is asking us, suppose that the queuing time t in minutes at a customer service desk has a probability density function, which is this. For k is an element of a real number, show that k equals to 1 over 64. So take the k out, so we know that the whole thing equals to 1. So k, the integration within that given boundary, so take that one. So that's going to be 16t minus t to the power of 3 d of t, the whole lot equals to 1. And the integration of that's going to be 8t squared minus t to the power of 4 over 4. And the k 0 to 4, I should say. So that gives me k, if I substitute that, would I get 8 into bracket 4 squared that gives me 16 minus 4 to the power of 4 over 4. So that's 64 minus 0 equals to 1. So that gives me 64, that's 128. 128 minus 64. So that's 64. So k equals to 1 over 64 as required. All right, let's move on to the next one. So the next bit is asking us the mean time. So that's going to be t, which is, so the formula says x times f of x d of x from 0 to infinity, or from negative infinity to 0 to positive infinity. Our x is t, 1 over 64 into bracket, there we need to integrate, t into bracket, and 64, no, not 16 actually, 16t minus t to the power of 3 d of t, and my upper bound is 4, my lower bound is 0. So if I expand that before I integrate, so that gives me 16t squared minus t to the power of 4. So that gives me an integration of 16 over 3. So 1 over 64. 16 over 3, t to the power of 3, t to the power of 5 over 5. 4 there, 0 there. So what do I get? So just substitution now. Playing around with the fraction. 16 over 3, t to the power of 3 minus 5 over 5. The whole, well, that bit is 0, so that's not important. What do I get? Well, that's going to be 64 times, so that's going to be 1024. All right, so what is that? 1000, so 1 over 64, 1024 over 3. What else do I get here? Well, that one is going to be t to the power of 5, which is the same as that, because that's going to be t to the power of, well, 4 to the power of 2, 4. So that's going to be 1024 again over 5. All right, so we could actually get the common factor out and do this much easier. 1024 into bracket 5 minus 3, then 5 times 3 is 15. So if I simplify this with that, so this with that, so that's going to be 1, that's going to be 16. So that gives me 2. 2 times 16 is 32 over 15 should be my answer, 32 over 15. All right, that's how we're supposed to be doing that question. Much easier. Playing around with numbers. What is the probability that a person has to queue for more than 2 minutes given that they have already queued for 1 minute? All right, so now the probability they're actually queuing for more than 2 minutes given that they already queued 1 minute or above. So now that is basically the same as saying the integration of x, well, so that's going to be that. Oh, actually, we have to use t because it's time. All right, now, so t there, t there, t there, t there. So that basically means, I think we have already integrated, didn't we? So that was x, well, actually we integrated. So which is this bit here, the integration. So all we have to use is use this and substitute, which is much easier. You don't need to integrate it again. So the k is 1 over 64 into bracket 8 t to the power of 2 minus t to the power of 4 over 4, 2 to 4. So that's going to be divided by, which is on my denominator. The same thing again. So now just playing around with fractions, that is. Once we have that, so if we solve this bit there, so that's going to be 16 times 8, which is 128, minus 64, isn't it? Yeah. $128. If I substitute 4, that's going to be 16. 16 times 8 is 128. So that's going to be 64, that bit there, minus, that's going to be the upper bound. So the lower bound will be 432, 32 minus, well, that's going to be what? 432 minus, so 2 to the power of 4 is actually 60 minus 4, actually. That's going to be 4, which is 28, isn't it? That bit there, divided by, oops, left there, 1 over 64. So that's going to be, again, the same thing again. So that's going to be 128. So we just have to look at what is in common. So that's going to be another 64 again. That bit there. Minus. So if you substitute 1 there, so that's going to be 8 minus a quarter. Yeah. So that bit there is 64. Yeah. Minus 28, which is 36, isn't it? So that's going to be 36 over 64, and this bit here divided by, what is this bit here? It's going to be a bit of a hassle one. So that's going to be 64 minus 38, 64. This bit is 64. And that bit is going to be 31 over 4, which is going to be 16. So this bit here there, 1 over 64. So that's going to be 256. 225, yeah, 225. So over 4. So 64 times 4, that's going to be 256, yeah. So 225 over 256, I should say. 256. Reciprocate the second fraction. So 36, which is basically the same as, what is that? 36. If I divide both of them by 9, is it 8? Oh, 9. No, hang on a second. I could divide both of them by 4, which is 9 over 16. Times 256 over 225. I could simplify this with that. So that's 1. That must be 16 times 16, 256. 16 times 9 is 144 over 225. So can I simplify? Divide this by 3. What do I get? So that's going to be 48 over, what is that? 75 to 7. Yeah, 75. Can I still simplify? Yes, I could, can I? It's going to be 16 over 25. Isn't it? Yeah, so that's going to be simplified. All right, that's a lot of fractions. All right, the last question, which is question 9. All right, now the shapes of 2 walking tracks are shown below. Track 1 is described by the function f of x, a minus x, x minus 2 to the power of 2, where the second track is defined by the function g of x, 12x plus b, x squared. So given that f input 0 equals to 12, and g, x equals to 1, y equals to 9, verify a equals to 12. So let's actually verify that. So that means if I substitute 12 there, a minus 0 to bracket 0 minus 2 squared. So that's basically 0. So a must be 12. All right, now g of x. So 9 equals to 12 1 plus b 1 squared. So that's going to be b 12. So b must be 12 minus 9, which is negative 3. Therefore, a equals to 12 and b equals to negative 3 as required. Verify f of x and g of x both have a turning point at point B. So this is the turning point. So g of x the value of x is 2. So now if I know my value of x is 2, I need to sub it in. So therefore my b value, the coordinates of b is 2 and 12. All right, that finishes that question. The last bit of the question is asking a theme park is planned whose boundaries will form the triangle 0 AB with O to be the origin at A, so the value of A is so the x value is k, the y value is 0. So now k, so my g of x is 12x minus 3b squared. So input k, 12k minus 3k squared. So now it's a triangle, so the area of a triangle is half base times height. So my base is k, my height is 12k minus 5. So that's going to be a half k 12k minus 3k squared. So that gives me 6a, yeah? So a is going to be 6k squared 3 over 2k cubed. So now dA over dk equals to 12k minus 9 over 2k squared. So the whole lot, because I want to solve for k, the whole lot equals to 0. So that means 12k minus 9 over k. Well, take the common factor out, I should do. That's the first thing. So k, the common factor, 12 minus 9 over 2k equals to 0. So k equals to 0, or 24 over 9, which can be simplified as 8 over 3, yeah? Because you divide both of them by 3. So the question is asking us to find the maximum area possible for the theme park. So now we know that the area is, so if I substitute 8 over 3, so that's going to be 6 to bracket 8 over 3 squared minus 3 over 2, 3 over 2, 8 over 3 cubed. So that gives us 64 over 3 minus, so that's going to give me 8. So that's going to be 3 over 2 times, that's going to be, what's that? 64. So that's going to be 2. $27, isn't it? So that's 1. That's 9. That's 1. That's 2. 56. What is that? What do I get? So that was supposed to be 9, isn't it? So that's going to be 8 over 9. So that has to be 9. Because 3 is squared. So that gives me 384 over 9 minus 256 over 9. So my area. So I want to get area. So what do I get? So that's going to be 8. That's 2. Because that's 7. It's going to be 1 over 9 units square. So therefore, the maximum possible area is 128 over 9. And that is the end of paper 1. All right, our next lesson we look at and paper 2. Until then, take care. All right, bye.